Okay, so what we're going to attempt to do here is to evaluate some trig functions by taking those special right triangles that we keep using and inscribing them inside of the unit circle. So we're going to start by just drawing a right triangle that is in quadrant 1, and we're going to evaluate the three major trig functions for unknown values of theta, where theta is that interior angle. So I'm going to pause and draw that triangle. Okay, so here's my triangle, and that's my unknown angle theta. If we are inside the unit circle, then I know that this length must be 1, because I'm using this circle that has a radius of 1, and the hypotenuse is that radius. Okay, so that's got to be a 1. So regardless of what type of right triangle this is, I'm going to call this length the length x, and this length the length y, which is going to make this point, which is a point on the unit circle, the point xy. I don't know what x is, I don't know what y is. All I know is that both of them have to be between 0 and 1. They can't be outside of that range if I'm in quadrant 1 and this is the unit circle. Okay, so if this is all true, which it is, we've drawn this very generic right triangle and we're inside the unit circle, then sine of theta must equal the opposite side over the hypotenuse side. Well, the length of the opposite side from theta is whatever y is. So sine of theta, in a generic sense, is y over 1, because the hypotenuse has a length of 1, making sine of theta equal to y. So this will always be true then. If we use the unit circle, sine of theta will be equal to the height of this triangle, or the y coordinate of this point. Cosine of theta is equal to the adjacent side over the hypotenuse. The adjacent side is x, and the hypotenuse again is 1, so then cosine of theta is equal to x. So that says that if I'm in the unit circle, whatever my bottom length is of this right triangle, or whatever the x coordinate is of this point on the unit circle, that is equal to cosine of theta. And then, if I want to find tangent, I need opposite over adjacent. The opposite side length is y, the adjacent side length is x. So that says if I need to know tangent, I'm just going to divide my y coordinate by my x coordinate. And that works great for quadrant 1. But B starts saying, well, what would be the sign of these if we were in the other quadrants? So what we're going to do to start to figure this out is we're going to draw some right triangles that are generic but have the same angular value as theta. And then we're going to do the same thing with those. So I'll pause and I'll draw those three triangles in the other quadrants. All right, so I've taken this right triangle and I've now reflected over the y-axis to put it into this quadrant, and then I reflected that one over the x-axis to put it in this quadrant, and then I reflected that over the y-axis to put it in this quadrant, which is leaving me with 3 more of this same triangle with that interior angle theta. Okay, so if this triangle is the same as the one in quadrant 1, but it's been reflected, then I'm going to call this length negative x, right? Because we're now going in the negative direction on the x-axis. And staying in quadrant 2, that's going to mean the height here is still y, right? This is still a distance from the x-axis up to this point that is exactly the same as the distance from quadrant 1. So that's going to mean that the coordinates of this point are the coordinates negative x, y. All right? Now let's move down into quadrant 3. In quadrant 3, my x value is negative x, but my y value is going to be negative y. So that means that these coordinates here of this point are the coordinates negative x, negative y. Now in quadrant 4, the height of this triangle is also negative y, same as in quadrant 3, and the length of the top edge of this triangle is still positive x. So that means the coordinates here are x, negative y. Now what I'm going to encourage us to do is to use these definitions that we came up with from quadrant 1 to help evaluate sine, cosine, and tangent in these quadrants as well. So in quadrant 2, what we're going to do is we're going to figure out what sine of theta, cosine of theta, and tangent of theta are. We defined that sine of theta is equal to our y coordinate. And cosine of theta is equal to our x-coordinate, and tangent of theta is equal to our y-coordinate divided by our x-coordinate. Since we know all these coordinates, that's going to become pretty easy now. Sine of theta, since it's our y-coordinate, is still just y in quadrant 2. But cosine of theta is our x-coordinate. And in quadrant 2, that's negative x. So cosine is negative now. In quadrant 2, tangent, since it's our y-coordinate divided by our x-coordinate, is y over negative x. So what you're going to notice here is that now that we're in quadrant 2, cosine and tangent have just become negative. However, sine remains positive. So I'm going to highlight sine to remind us that that one is still going to be a positive value. Let's move on to quadrant 3. In quadrant 3, if I want to find sine of theta, all I need is my y-coordinate, but it looks like that's negative now. If I want to find cosine of theta, all I need is my x-coordinate. It looks like that's also negative now. If I want to find tangent of theta, I need to take my y-coordinate and divide it by my x-coordinate. A negative divided by a negative is a positive, so this is actually going to work out to be a positive number here. So tangent in quadrant 3 is also positive. Now in quadrant 4, to find sine of theta, all I need is my y-coordinate. Looks like it's negative. To find cosine of theta, all I need is my x-coordinate. That turns out to be positive. And to find tangent of theta, I need to take my y-coordinate and divide it by my x-coordinate, which is going to be a negative number. So it looks like in quadrant 4, cosine is positive. So here's what this means. If I'm in quadrant 1, no matter what I use, I'm going to have a positive value. If I'm using cosine, if I'm using tangent, if I'm using sine, I'm going to have a positive answer. If I'm in quadrant 2, the only function that's going to give me a positive result will be sine. If I'm in quadrant 3, that'll be tangent, and in quadrant 4, that'll be cosine. So a quick rule that I use to remember that is that all of them are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. ASTC. And a little phrase I use to remember that is add sugar to coffee. If that helps, great. If you're good at just remembering ASTC, great. If you want to go through reasoning this out every single time, that's fine too, but that's going to be a little time consuming. So let's do this example. This is an example of a type of problem that we would have where we would need to actually implement this information. What we're going to do is we're going to calculate cosine of 120. So to start, I'm going to sketch a little unit circle here for me to use because I know that I'm going to put my special right triangle inside of this unit circle. And 120 degrees would put us in quadrant 2. So let's say that that's here. Say that that's a 120 degree angle. If that's a 120 degree angle, then this special right triangle must be a 30, 60, 90 right triangle because 120 degrees leaves me with a 60 degree reference angle. And since this is a right triangle, that's a 30 degree angle. Now, if I'm inside of the unit circle, then the hypotenuse has a length of 1. So what we already know from adjusting these triangles is that when I label the bottom edge here, it's the side opposite the 30 degree angle, that's going to be a length of 1/2. And when I label the side of this triangle, it's going to be radical 3 over 2. This becomes very easy at this point because of what we just did. We know that cosine is just our x-coordinate, whatever our x-coordinate is. Okay? So we just have to be careful that when we label these, we have the appropriate signs. This 1/2, since it's in quadrant 2, would have to be a negative 1/2. And now, when I do cosine of 120, all I need is my x-coordinate of this point. So what are the coordinates of that point? Well, that would be the coordinates negative 1/2, radical 3 over 2. So cosine of 120 is negative 1/2. And if I wanted to find sine of 120, sine of 120 would be from that same angle, but all I would need would be the y-coordinate. The y-coordinate is radical 3 over 2. So sine of 120 would be radical 3 over 2. If I wanted to do tangent, it would be a little more complicated because tangent requires me to divide my y-coordinate by my x-coordinate. So that's going to be radical 3 over 2 divided by 1/2, negative 1/2, which is the same as radical 3 over 2 times negative 2 over 1. Remember that when we're dividing by a fraction, I would much rather multiply by the reciprocal of this fraction to make things a little easier on myself. I'm going to cancel these 2's because 2 divided by 2 is just 1. So this is going to leave me with negative radical 3 over 1, which is just negative radical 3. So tangent of 120 degrees would be negative radical 3. And that's it. Okay, it's going to get a little bit more complicated because I could give you some more complicated angles. But every angle I give you is going to have a reference angle that is either 30, 60, or 90 degrees, or 30, 60, or 45 degrees to start.